Hello guys, welcome back. So here we have another question on communication systems from GATE 2023. Let x of t be a wide Gaussian noise with power spectral density half watt per hertz. If x of t is input to an LTI system with impulse response e power minus t u of t, the average power of the system output is dash watt and round it off to 2 decimal places. So what they have given, x of t is wide Gaussian noise, right? So this we are inputting to a system whose impulse response h of t is e power minus t u of t, and let's say we get some output y of t. They are asking the average power of y of t. So coming to the input, what does wide Gaussian noise mean? It means that its power spectral density is going to be constant, and that constant is given as 1 by 2. So this is xx of t, and this is in power domain. But here we are dealing in signal domain, right? So if you have y of j omega, it will be nothing but x of j omega into x of j omega. So now if we have to go to the power domain, what we have to do? We just have to square them. So xy of j omega is equal to h square mod of h of j omega whole square into power spectral density of my input. And since here they have given in terms of hertz, we can just stick with f instead of omega, which is the angular frequency and whose unit is radian per second, and the f it is hertz. So it will be h of f whole square into xx of f. So then what will be the average power? Average power is nothing but, so now if you see, this has a unit of watt per hertz, and this is just a transfer function, so it is unitless, right? No unit. So this will have a unit of watt per hertz, and average power unit is watt, which means that we just have to integrate this term. So integral from minus infinity to infinity xy of f df. So this should be my average power, okay? And that power average is nothing but integral minus infinity to infinity mod h of f whole square into s x of f into df, and xx of f is half, so it is half integral minus infinity to infinity mod h of f whole square into df. So this you can find it in two ways. You can either use Parseval's relation, in which case this is actually equal to half integral minus infinity to infinity h square of t dt, or other way is to find h of f from h of t and then directly use this. Okay, so both ways we can try it out. So here h of t is e power minus t u of t. So my integral minus infinity to infinity h of t square dt is nothing but integral minus infinity to infinity e power minus 2t dt, and u of t is there, so my integral will limit from 0 to infinity. So this is e power minus 2t by minus 2 from 0 to infinity, which is e power minus 2 into infinity minus e power 0 divided by minus 2. So this is 0, this is minus 1, so it is half. So can we actually find h of f from here? So h of f is nothing but, so you would have known h of omega, j omega equation. So in that case, this is integral h of t e power minus j omega t dt from minus infinity to infinity. And once we go to f, here in this equation nothing is going to change. So it is just integral minus infinity to infinity h of t, instead of omega we are going to write it as 2 pi f t dt. But in the inverse Fourier transform, right, if you have to write h of t in terms of h of j omega, you have 1 by 2 pi factor here. So h of j omega e power j omega t dt. So this is your inverse Fourier transform. Similarly, if you have to write it in the just f variable, this 2 pi factor will go away. Again, this is not dt, this is d omega. So d omega is nothing but 2 pi f. So once you write it, it will become 2 pi into df. So this 2 pi will cancel. So you will just have integral minus infinity to infinity h of f e power j 2 pi f t df. So if you look at this equation and this equation, they have almost similar form except for this sign change. So it is easier to actually remember this than going with your angular frequency terms. And here again, if you just replace this as omega, here you will write it as d omega, but this will be a mistake because this d omega and df are differing by a factor of 2 pi, right? This is coming because of the units. So here the units is per hertz, it is not per radian per second. If it is per radian per second, then you have to use d omega. So by multiplying by df, we are actually removing this hertz. So it is watt by hertz into hertz, which is equal to watts. Here you can't put radian per second, then you will be making a mistake. So you have to be careful. Okay, so coming back here, for e power minus t u of t, what is your Fourier transform? If you remember the formula, it is easy for you. But if you don't remember also, you can quickly derive. So anyway, it is 0 to infinity e power minus t e power minus j 2 pi f t dt. So this is nothing but 0 to infinity e power minus of 1 plus j 2 pi f into t dt. So this is equal to e power minus 1 plus j 2 pi f t divided by 1 plus j 2 pi f from 0 to infinity. And if you substitute, you will actually get 1 by 1 plus j 2 pi f. Now we need to find integral minus infinity to infinity mod h of f whole square df. So this is nothing but 1 by modulus of this square is 1 plus 2 pi f whole square df. So if I put substitution of variables, 2 pi f equal to some, let's say whatever, x or omega, whatever. So what will you get? Your integral, this df will become dx, which is equal to, so dx by 2 pi is df. So 1 by 2 pi, integral limits will be same. So it will be 1 by 1 plus x square into dx. So this is nothing tan inverse of x from minus infinity to infinity. So this is equal to 1 by 2 pi into tan inverse of infinity is pi by 2 minus of minus pi by 2. So this is actually equal to pi. So this also comes out to be 1 by 2. So we have also verified. But this is not the answer. Power average is what? Half times this. So P average is half into whatever this integral, right? So this is equal to half into half, which is equal to 1 by 4. If you have to write it in decimal, it is 0.25 watts. So when solving in this method, if you actually miss, instead of df, if you write d omega and here 1 plus omega square d omega, here you will actually miss out on the factor of 1 by 2 pi. So this will directly be just pi by 2 plus pi by 2, which is pi. So your final answer will be pi by 2 instead of 0.25, which is totally wrong. So you have to always be careful with the units and whatever you are multiplying with it and integrating. So the answer for this is 0.25.